Today's notes are on identity and inverse matrices. The identity matrix have a main diagonal of 1s and all the other entries are 0. So whether it's a 2 by 2 or a 3 by 3 matrix, they both have the main diagonal of 1 and then everything else is filled in with 0. The identity matrix is represented with the letter I. The inverse of a 2 by 2 matrix. The notation for an inverse is the letter of the inverse raised to a power of -1. It doesn't have anything to do with exponents. It is just the notation to show that you're taking the inverse. Your steps are going to be first to find the determinant and then put it in the denominator of a fraction. So you'll have 1 over whatever your determinant is. Then you're going to take your matrix and do the switchy. This is switching the diagonal down entries and making the diagonal up entries the opposite sign as what they started. Then you're going to multiply 1 over the determinant into your switchy matrix. The result is the inverse matrix of the original. You can check your work by multiplying the original matrix and the inverse together. The product should be the identity matrix. Right. The inverse of matrix A, if A is A, B, C, D, is 1 over the determinant of A times your switch matrix. So you can see the diagonal down entries have switched spots and the diagonal up entries have switched signs. For example 1, let's go through the steps and find the inverse of this matrix. So step 1 was to find the determinant and put it in a fraction under 1. So the determinant of 3, 1, 4, 2 is equal to our diagonals down, which is 3 times 2, minus the diagonals going up, which is 4 times 1. So I get 6 minus 4, or 2. So our determinant is 2, so I'm going to put that under 1. So I'm going to have 1/2, and you're going to multiply that by the switch matrix. So my diagonal down entries will trade spots, and the diagonal up entries will stay in the same spot, but their sign will flip. So my last thing to get my inverse matrix is going to be to multiply 1/2 into this matrix. So 1/2 times 2 is 1. 1/2 times -1 is -1/2. 1/2 times 4 is -2. And 1/2 times 3 is 3 over 2. This is our inverse matrix. Please try and find the inverse of matrix B. If you multiply two matrices together and your result is an identity matrix, then the original two matrices are inverses of each other. So you must check that A times B equals the identity and that B times A equals the identity. So we're going to check and see if these two matrices are inverses of each other. So first I'm going to check A times B. Alright, so we need to remember that you're going to be multiplying across the rows and down the columns. And my answer matrix is going to be another 2 by 2 matrix. So to start, I'll have 3 times 2 plus -1 times 5. That's me, my top left entry. Then to get the top right entry, I'm going to use the first row and the second column. So I'll get 3 times 1 plus -1 times 3. Then I can look at the bottom left entry, so I'm going to use row 2, column 1. So I get -5 times 2 plus 2 times 5. Then I'm going to use row 2, column 2, so -5 times 1 plus 2 times 3. Alright, so if I go through and try and simplify these, I get 6 minus 5, 3 minus 3, -10 plus 10, and -5 plus 6, which does simplify to the identity matrix 1, 0, 0, 1. You do also have to check B times A to make sure that is also the identity matrix. If it does not give you the identity matrix, then the two are not inverses. So you must check them both. Alright, using the same setup here, I'm going to go row 1 times column 1. So 2 times 3 plus 1 times -5. Then I'm going to use row 1, column 2. So 2 times -1 plus 1 times 2. For my bottom left entry, I'm going to use row 2, column 1. So 5 times 3 plus 3 times -5. Then row 2, column 2, 5 times -1 plus 3 times 2. So if we go through to simplify, we get 6 minus 5, -2 plus 2, 15 minus 15, and -5 plus 6, which again gives me my identity matrix 1, 0, 0, 1. So because they both give you the identity matrix, you can say that these are inverses of each other. We can then use inverses to solve for a missing matrix. So when solving for a missing matrix, you cannot divide, so instead we multiply each side by the inverse. This allows us to solve for the missing matrix. So a matrix equation looks like matrix A times X equals matrix B. So your steps for solving a missing matrix: first, find the inverse of the given matrix. Then multiply both sides of the equation by the inverse. Make sure you watch out for the order. You must multiply the inverse first and then by the matrix. After multiplying, you will have the identity matrix times X, and that'll be equal to your answer matrix. So example 4, we're going to go through and solve the matrix equation A times X equals B for the 2 by 2 matrix X. Right, so our first step was to find the inverse of matrix A. So in order to do that, I need to start by finding the determinant. So our determinant of 4, -1, -3, and 1. I'm going to take my diagonals down and subtract it by the diagonals going back up. So I get 4 minus 3, which is equal to 1. Your next step in finding the inverse was to take 1 over the determinant and multiply by the switching matrix. So I switched the diagonal down entries and I switched the signs on the diagonal up entries. Multiplying anything by 1 is going to be itself, so my inverse matrix is just 1, 1, 3, 4. Your next step was to multiply both sides of the equation by the inverse, making sure you put the inverse first. So I'll have 1, 1, 3, 4 times 4, negative 1, negative 3, 1. And then our x is equal to the inverse matrix again, times 8, negative 5, negative 6, and 3. So we're going to go ahead and perform these multiplications again. Remember, you're going across the rows and down the columns. So my 2 by 2 matrix answer we're going to get here, we'll get 1 times 4 plus 1 times negative 3 in the top left, then 1 times negative 1 plus 1 times 1 in the top right. In the bottom left, I'll get 3 times 4 plus 4 times negative 3. Bottom right is 3 times negative 1 plus 4 times 1, and this is still by our matrix X. And then if I perform the multiplication again on the second matrix, I get 1 times 8 plus 1 times negative 6. Then I get 1 times negative 5 plus 1 times 3. Then we get 3 times 8 plus 4 times negative 6 and 3 times negative 5 plus 4 times 3. Right, to continue, I'm going to simplify. So I get 1, 0, 0, 1. So I get the identity matrix on the left, which we should, and that's times matrix X, and it's going to be equal, so if I go ahead and simplify that matrix, 2, negative 2, 0, negative 3. So what this means, if we would go back and look at the original problem, this matrix that we found, the 2, negative 2, 0, 3, if you multiply 4, negative 1, negative 3, 1, by the matrix that we just found, you should get our answer now of 8, negative 5, negative 6, and 3. So we're able to solve for the missing matrix by multiplying both sides by the inverse. Please flip to the next page and try example 5 on your own, following the same steps that we did with example 4. You can also see if you can figure out example 6. We will go over example 6 tomorrow, as well as example number 5.